Hello everyone and welcome to Universe Sandbox 2. I'm your host today and just want to wish you a Merry Christmas, Happy Holidays, Happy Hanukkah, Happy whatever you are celebrating right now. And if you're not celebrating anything, I still wish you yeah, a good time and yeah, I still hope you enjoy this time of year, no matter what you're doing or celebrating. 2017 has been quite a bit of a year. A lot of ups, a lot of downs. Uh, so much has been going on this year. Like, for example, with this whole thing in North Korea, possible World War III, but also a lot of scientific discoveries this year, like for example, yeah, with the gravitational waves, for example, as well. I will get to that shortly, but yeah, I have a bit of a Merry Christmas here for you guys. I'm not gonna let this run because last time I let this run, had my computer crashed, so I'm not gonna run this. But yeah, let me get to that gravitational wave thing. Just a moment, and okay. Now, earlier this year, they've discovered um, these gravitational waves. Now, they're formed when two massive objects, like for example two black holes, collide and merge, and yeah, the gravity from the two black holes bend the space and time around them to the point where they form these like waves almost in the space time. And earlier this year we've actually detected it, and yeah, Einstein actually predicted these gravitational waves um, almost 100 years ago, and they weren't predicted not once, not twice, but four times. Or was it three times? I'll have a look at it again, but yeah, this is just gonna be like, oh my gosh, what just happened? What happened? Oh my gosh. Um, yeah, let me try that again. That failed. So let me just quickly try that again because that was a big fail. Almost wanted to say something else. Um, yeah, I hope this time it works. Oh my gosh, it just failed again. What the flip am I doing wrong? No, man. Ah, alright, let me try it with, something else. Not pulsars, but, let me try it with a black hole. Hopefully that will work. Um, yeah, this here is a black hole, and let me see if I can, hopefully this time it will work. Okay, because I want to try and demonstrate what's going on. Oh, oh my gosh! No! No, man. Yeah, one fail. Oh my gosh. Okay, let me try something with a little bit less mass. I think that's the problem. They're having too much mass, but this should work. But with neutron stars or black holes, when they merge and collide, yeah, this is what would happen. This is what happens. They they orbit each other in this way, and over time they slowly, because of gravity, they slowly come together, and the closer they get, the faster they orbit each other. Eventually they merge, and okay, let me try and demonstrate it here. And okay, it should show any moment now, but I think you guys can already slightly see that they're coming towards each other slowly, and as they get closer, they start orbiting each other faster and faster. Eventually, as they do this, they start the gravity of the two black holes or neutron stars. They start producing gravitational waves. Okay, let me just get a little bit outwards, just a little bit, and eventually, whether it be black holes or neutron stars, they eventually collide, and yeah, if it's two neutron stars, then we have something like this. Okay, a like a supernova basically. The end result may be perhaps a black hole. It depends on how massive for example, the neutron stars are. Okay, if it's two neutron stars, then you might end up with a black hole, with some of the material being blown off as a supernova. And in this material here, you can have whole range of heavy elements like gold, lead, silver, uranium, for example. And yeah, this is how some of the heavier elements are formed during a neutron star collision. Now, the other thing that we discovered this year that I've actually talked about as well is the Kepler 90 system, where they discovered the 8th planet. Yeah, I actually talked about that one in a previous video. Now the other major discovery that we made this year is with the TRAPPIST-1 system. Let me just quickly find it here. It is here, just need to quickly find it, and here it is. Now this year as well, we discovered 3 planets within the habitable zone of the TRAPPIST-1 system. Now the TRAPPIST-1 star itself is a relatively small star, just under 84 times the mass of Jupiter, and it's classified as a red dwarf. Now it is just a little bit. I know, man, that's not what I wanted to. I forgot that it was still running. Just a moment, guys. Yeah, let me try that again. Just wanted to give you guys like a comparison of how big the star is compared to Jupiter. Now, as you can see, there is TRAPPIST-1 itself is just slightly bigger than Jupiter itself. So okay, one might think that the more massive a star is, the bigger it is. Kinda true, but if you if you add mass to a star, or if you add mass to a planet like Jupiter, it does increase in size at first, but then at some point gravity causes this object to contract, forming first a brown dwarf, and then eventually a great dwarf. I will talk about that in another video. But yeah, at first the star contracts and it increases in density, which is why great dwarfs like TRAPPIST-1 are so small, but they have a very high very high density. Our sun has an average density of about 1.4 tons per cubic meter, while small red dwarfs like TRAPPIST-1 here can have a density of about 70 to 80 tons per cubic meter, which is very dense for stars. Okay, so let me just undo this and then just remove this. Now with the planets themselves, we first knew of 4 planets around this star, but then this year we discovered 3 planets within the habitable zone of the star, which is this green zone here, which is TRAPPIST-1 E, F, and G. These are the 3 planets that we discovered this year. And now what makes this discovery so interesting as well is that all these planets are roughly Earth-sized, ranging in size from, let me just quickly show this, ranging from 1.13 Earth size and radius to 0.784 Earth radius. So in radius, this is the TRAPPIST-1H is the smallest. Also, it has the smallest 0.4 times the mass of the Earth, so just under half the mass of the Earth, while TRAPPIST-1C has a mass of 1.38 Earth masses. So it's possible that these planets might have Earth-like conditions. However, with red dwarfs, that's a bit of a problem. Let me just slow down time a bit so you guys can see, and yeah, let me just, no, just missed one. Yeah, as you guys can see, red dwarfs like this, like TRAPPIST-1, produce these massive ejections, massive solar flares. By this one star, I actually forgot the name of it, but over a period of 42 days, they've counted 84 of these kinds of flares. So red dwarfs like this are known as flare type stars because they produce massive amounts of flares, and if one of them hits a planet, then it can actually strip the atmospheres of these planets away in just a few thousand or perhaps a few million years. Okay, I don't have an exact number right now on me, but in about a million years or so, these kinds of eruptions can eruptions and flares can actually nearly completely strip a planet of its atmosphere and water. Go away, that thing. Um, so red dwarfs aren't exactly most the most likely type of star that can sustain life for very long. Well, they can, but only because they live for billions of years. Our sun can last for about 10 billion years, but red dwarfs like TRAPPIST-1 can last for 100 billion years, or even longer. So the very first red dwarfs that were born just after the Big Bang, if there were red dwarfs at that stage already, they would still be they would be toddlers basically. But other types of stars like the sun, for example, or sun-like stars, um yeah, stars like the sun, if they were born during the early stages of the universe, they would have been they would have died long ago. And that's about it for this video. And yeah, I hope you guys enjoy this time of year, and I'll be seeing you in the next one. So let me just end this video with a bang, and there goes the TRAPPIST-1 system. Well, at least in this animation anyway, and I think we just completely lost all the planets. Great. I have no idea what's going on anymore. Oh my gosh. And yeah, that's the second supernova for this video, and I will be seeing you in the next one. And I hope you enjoy this time of year. Bye.